Okay, now we have the record light. Okay, so this is available on files test related. Do a search on 26, it'll come up. Okay. Someone needs to remind me to send out an email regarding start time tomorrow. We're just going to start at 11 tomorrow. Okay, define an acid. Remember, there are many definitions of an acid. This is the earliest one. But in your next class, you're going to have one definition is it's proton donor, because H plus is a proton. There's no electrons. So anyway, there's a number of them, but this is the simplest one. Okay, so the key here is disassociate and H plus. If it doesn't disassociate, it's not an acid. There are three situations regarding acids: strong acid, weak acid, and not an acid at all. Most acids are weak. All biochemical acids are weak except for hydrochloric in your stomach. Everything else is weak. There are millions of weak acids. Millions. And only a few strong, only 7 strong ones. In Breaking Bad, he used a strong acid. Remember the scene?
Where they melted the body to bath.
The bathtub fell to the floor.
Yeah.
That was
Disgusting.
that was HF, hydrofluoric acid, really a strong acid. It eats flesh quite nicely also. That's why they wanted to use it. Okay, and then likewise for a base, it disassociates a hydroxyl ion, OH minus. Okay, how can water be both an acid and a base? Well, if you look at water like this, H2O, here's the H and here's the OH. It's a very weak acid, but it is an acid and it's also a base, because the H disassociates and the OH also disassociates. What's an acid-base indicator? Phenolphthalein. You don't need to know the name of it, but that's the most common one in use. 99% of acid-base indicators used are phenolphthalein. Very, very common. It works quite well too. Okay, so an acid-base indicator shows when the endpoint is reached. Now, there's something called an equivalence point. This is the technical neutralization points, the equivalence point. Now, what you have to do when you determine an indicator to use, you have to look at the indicator's endpoint and the equivalence point. They should be the same or close to the same. Okay, we didn't talk about equivalence points, but that's technically, that's what they're gonna talk about in your next class. And then, you know, match up your endpoint of the indicator to the equivalence point. And there's one equivalence point per H that comes off. So if you have a diprotic acid, two H's come off, so you have two equivalence points. Phosphoric acid has got three, vitamin C's got three, so that's three equivalence points. Okay, correct the following. Okay, so what's wrong with this? Hmm? Got a 3D there.
I see a little p and a big P, those are two different elements.
That's true. It should be a little p though.
Oh,
No, that's a valid point. If you would have put that down, I would have said,
okay. I'm like, is it a different one of phosphorus?
yes, it's supposed to be all lowercase. The D's come after 4S. So in other words, this needs to go. Because you can't have a 3D unless you have 4S. So after the 3P6, you go 4S2, then the 3Ds. Okay? So then the 3D6 there. But you've got to have the 4S2 for the Ds come. Okay. Cobalt, write the electronic configuration. Now remember, there's the orbital representation and the electronic configuration. Okay, the orbital one just adds orbitals to electronic configuration. Okay, so we find cobalt. Cobalt is 27 up there. So it's right in the middle of the Ds, and it's the top of the D, so that's a 3D there. How far over is it? Is it 7 over?
9, 8.
Yeah, 7 over. Okay, so we need to go up to a 3D7 now. Okay, so let's take the journey on the periodic table here. Okay, so we need to go to here. We're going to go 1s2, 2s2, 2p6, 3s2, oops. Or S2, and then we're going to go 3D7. So that's the electronic configuration. Next question is, what's the orbital configuration for chromium, Cr? Chromium is also in the D, and that's 5 over. So it's gonna be just like this up here. Well, the one just did anyway. Okay. Now from the electronic configuration, we're gonna do the orbitals. So there's all the S's have one set of orbitals. The P's have three. D's have five. And that is 5 over, right? No, it's 4 over. Okay, so this is the orbital representation. So the first thing you do is you write the electronic one and then fill in the orbitals afterwards. Now, chromium is in your next chemistry class, chromium and copper are special cases. And you're going to go into detail why it's a special case. But for us, that's electronic configuration for chromium. Okay. Okay. This is a titration problem now. Okay, we're titrating, and we end up with 25.67 milliliters. That's when the endpoint turns pink, light pink, I should say. But we've got to do it in liters. Okay, so first thing is convert all milliliters to liters. So that means we start with liters. You're going to move the decimal point over 3 places. Okay, times, remember, liters times concentration gives us moles. And that's equal to, in liters now, so it's going to be 1, 2, 3. So that's, and this is the acid concentration in moles per liter. At the endpoint, when neutralization occurs, this is true. Only at the endpoint or the equivalence point. Otherwise, this is not valid. Okay, now we can solve for the acid concentration. So we're going to divide both sides by well, that cancels. Leaves us with acid concentration. Okay, so So 3 sig figs.
What did you divide on that side? Because you canceled those two out.
Hmm?
When you were just applying, how did you put it in the calculator? For the other part that was canceled out?
Yeah, because you wanted to isolate the concentration.
How did you put it in? Yeah. You don't do anything for it. Oh, you
It's also you cancel, oh, so you simply are dividing, but you don't have this.
Yeah, you would do the opposite operation. Be multiplying here, the opposite of multiplying is dividing. That's why it cancels.
It's not like a.
Okay.
Okay, any questions about this? Yeah. Formulas for what? Well, you have to remember that concentration times volume equals moles. So that's what we're taking advantage of. We know the base concentration and we know the base volume in liters. Okay, and that's equal to the acid volume and the acid concentration at endpoint. But we don't, and the question is what is the acid concentration? So we solve for that. Was that what you were asking? Okay. Yes, this is real important to know. Okay. What's the separate hydrogen ion and chloride ion concentrations of the following acidic solution? Okay. Ion concentration is, remember, moles per liter. So we need to get moles and the volumes given. Okay, so we have and here's the reaction. We have hydrochloric acid goes to H plus plus. Hey, is that balanced? Yeah, balanced. So that means if we know the moles of that, that's equal to moles of H and moles of Cl minus. Because the balance equation coefficients are 1 to 1 to 1. Now, we're given the grams or the mass of hydrochloric acid. We know the molar mass of hydrochloric acid from the periodic table. So H is 101, chloride is 3545. So that's 3646 grams per mole. So what do we multiply to get moles? Well, molar mass. Grams have got to cancel, so the grams have got to be in the bottom. So grams cancel gives us moles. Now we've got the volumes 135. So it's going to be Okay, so that's H and it's also Cl. Remember, square brackets is the same as moles per liter. And that falls out because of the balanced equation. Always write down the balanced equation if anything's going on. You should always refer back to that. Okay, so any questions about this guy? Right.
You wrote down the hydrogen atomic mass. What's below hydrogen? I see it as 3L. Okay, I was a little confused. It should be Cl, right? Okay. Thank
Yeah,
you.
Cl.
Thank you.
Why not put 3L?
Maybe your brain was ahead, so I was like, oh, 3.
Yeah, maybe because of 35. Very good. It's saving my. Okay, what's the volume in liters of a gas balloon if the gas pressure is 2.3 atmospheres, temperature is 14.5? And this goes back to your question. Doesn't matter what gas is in that balloon. Okay, so we're gonna, and I've got these formulas down here. Okay, I give you the R values. Remember, we're using Kelvin temperature now. And this is the relationship between Kelvin and Celsius. So always convert to Kelvin. Basically, you're going to add 273. Okay, and then this is the relationship, the ideal gas law, PV is equal to nRT. N is moles, R is the gas constant, which is right here. There's different ones depending on the units you're using. But the units we're using in this class is going to be 0.0812. Okay. So let's go back up to here. All right, so we're going to be using PV and RT. Okay, and we want to know the volume. So if we solve for volume, it's going to be that. Divide both sides by pressure. So we know N notice, I mean, we know R. Notice we didn't state N. Assume it's 1 mole. Okay, and T is 287.5 Kelvin. Pressures 2-3 atmospheres. That'll be the volume. Notice it's not STP, because at STP it would be 22.4. We're non-standard conditions now. So we're looking at two sig figs. Is that guy there? Okay. All right, now we've got changing conditions. When conditions change, we're going to use this relationship. We have initial conditions, final conditions. Okay, so we're going to say this is okay, and did we add any gas or take away any gas? No. So N cancels. It's the same value. If we added gas, then we need to know how many moles we've added or taken out. Okay, so we've got temperatures here. Let's convert them to Kelvin. Yeah. Oh, wait a minute. Yes, except I should put F over here, not I. Yeah, thanks for pointing that out. Okay. Remember, Kelvin is always bigger than C. So that means you have to add to get bigger. Okay, so initial pressure is 162 atmosphere. Initial volume is I didn't give the initial volume. Let's say it was 215 liters.
It's okay.
What's your?
Everybody timing the fact that the fact that it's sort of plans. I don't know if it was.
Okay. So we're trying to find the final volume. So there are 6 variables there. That means I have to supply 5 of them to get the 6th one. Okay. That's why I knew right away something's missing here. Okay, now we just solve for a final volume. So we're going to cross multiply. That means we're going to multiply both sides by so that cancels. I'm going to divide both sides by 652 atmospheres. So we're left with final volume. Sometimes your teachers will teach you cross multiply. So we just, if it's on the bottom, when you bring it to the other side, it has to change sides of the fraction bar, and vice versa. Okay, did everyone see where I got the solve for the final volume? All we've done is I've canceled out everything except the variable final volume. Okay, let's see here. Okay, so when conditions change, you need to use this formula. When all you're trying to calculate is a gaseous volume, use this formula.
The left-hand side, are you multiplying top to top and bottom to bottom, or are you crossing?
You're going to multiply everything on the top, hit the divide key on everything on the bottom, just like we did for stoichiometry. Okay, so this is going to be a shorter test than the last one. Yeah. No. No, because it's just a week of material. No. Yeah, our question was, can she use her own periodic table? As long as there's no notes on it except for the SP and all that stuff. Yeah,
These kinds of problems with the practice on, like practice questions.
don't I have worksheet practice ones for everything?
Okay, I just.
Yeah, it's under, I know. Okay. Just go, file, unit. The problem is, gases are gonna be in unit 5. As far as those worksheets are concerned, because I had to rearrange all that, because I got evaluated and they said, I can't have 5 units, too many units. So I had to merge some together, so. Do a search, file search. Yeah. In unit 4. This one?
Yeah.
I sent you email like last week. I don't know if, did you see it? It was about regrading, late submission. Do you still do that? And then I have to still catch up on like the latest ones. I sent which ones I needed regraded. Excited for script.
All right, what's your first name?
Valentina or Val? Tina? I don't know if it, but my full name or nickname.
Right.
It was for like a week.
Oh, good.
You found it? Yeah.
It's under Val.
Okay, Val. Yeah. All the regrading stuff I need.
Yeah, why don't you resend it to us at the top?
Okay. Yeah, I'll resend.
Don't forward it, just do a new.
Okay, sounds good. Thank you.
Otherwise, forward something, it'll go back down here and add to that at the bottom.
Okay, yeah, I'll resend it.
Randy will.
Okay, I'll try to finish other things before I resend the email.
Yeah.
Okay, thank you so much. I want to know, are you grading my exam?
Yeah.
Bye. Huh?
Two piles of exam,
Oh,
the city and Sierra,
okay.
so. Both of them are on my desk at home, so. Don't worry, it'll get graded.
Okay.
Send me the emails, remind me. Please.
Thank you.
I don't know. Why did I get like 90% on the test?
What?
Why did I get 90% on the test? Like, what did I do wrong? No.
I still can't hear, I mean,
On the test, like, I really like that I should get more because I think my answers are